Okay, good afternoon to one and all. Welcome back to our online class. As you all know that in our last class we've discussed about routers, hubs, switches, right, and so on. So these are the some things in our last class, and network interface card also. I hope you can still remember what all these things are. And if you have forgotten, please go back and revise because all these things will be tested in the exams. And maybe after 1 or 2 weeks, I will run a quiz and everyone is to do it. So please go back and revise all these things. Now let's start with our class proper, today's class. Now we'll be talking about data transmission specifications. Now data transmission specifications specify the rules and speeds at which data is transmitted over the network. Protocols specify the rules and bandwidth specify the speed. So two things: protocols specify the rules, and bandwidth specify the speed. Protocols, what is that? Are rules for exchanging data between computers. The standard protocol for the internet is TCP, that is Transmission Control Protocol, and IP, which is Internet Protocol. So that is the standard that is used to access the internet. Right, so very important, you should know about protocols and TCP and IP. So what we be looking at, and whatever is here in the slide, this slide, all these things are discussed later in the slides. Right, so I'll not go in depth here. We'll go in depth once we'll discuss more. Now, TCP IP is a two-layer protocol, right? TCP and IP, that is two layer. One is TCP, another one is IP. The higher layer is TCP, which manages the assembling of a message file into smaller packets that are transmitted over the internet and received by the TCP layer that reassembles the packets into the original message. Right? So this process is called packetization. Right? If you have answered the worksheet, you must have seen these questions in that worksheet, right? And also this is in the notes also in that worksheet, right? So packetization is a process where message or file is broken into small packets and it is transmitted over the internet and received by the TCP layer that reassembles the packets into the original message. Right, so anything you send, for example, you are sending something from your side, your phone to another person's phone, right, over internet. Maybe you are texting. So all those things, for example, you're texting hi, right? Prishal is texting hi to Rishal. So that hi is only two-letter word, H and I. Now that is broken into small packets, right? And it is transmitted over the air, right, to another person's phone, right? And that is the process of packetization, right? It is broken into small packets, it is transmitted over the air, and it is when it is transmitted, it is jumbled up, right? Hi can when it is transmitted, it will be maybe IH, not HI, and it is in small packets, so it will be all jumbled up. So once it reaches the other person's phone, then it is reassembled. That means again it will go back to normal, and the person who receive Prishal is sent hi to me. Right? So original message will be seen by the receiving person. That is called packetization. Now next one, the lower layer, which is internet protocol. It handles the address part of each packet so that it gets to the right destination. Sometimes you create one message and send it to plenty people, right, in Viber or in Messenger, right? So how you know it will go to the right person, right? So this the internet protocol will handle that, right? It will see that the address is correct, and it will see that the message or the packet reaches the right address to the right person, right? And just like when you email something or DHL or something, right? People uh, bring it to your doorstep, right? How? Because they have the address, they have the location where you are, where's your house, right? So similarly, in internet, every device has a address, right? Your laptop, your computer, your mobile phone has a address. It has a IP address, right? Even your Viber account has a address, right? Your Viber account has uh, it is connected through your mobile number, right? So
Yes.
it is a address. It is a address, mobile number, right? Your messenger account is your ID, right? Your username and password, your ID. So everything has a address. Now let me continue. It says it handles the address part of each packet so that it gets to the right destination. Each gateway, that is the router or server on the network, checks this address to see where to forward the message. Even though some packets from the same message are routed differently than others, they will be reassembled in the original order at the destination. So this process is known as identification, right? Identification comes from the word identity, right? Identity of anyone, for example, your identity is your name, right? Your place of birth, where I live, right? My identity is where I live, what is my name, all those things, right? So the message to whom it is sent, there's the identity, right? Identity of the receiving device or receiving computer or whatever, right? So remember, TCP manages the assembling of message of file into smaller packets, and it is transmitted over the internet, and then it is later reassembled into original message. That's packetization. Whereas IP handles the address part, right? Address part, so that the message goes to the right person, and later it is once it reaches the right person, the destination, it is reassembled. It is assembled again in the original order. The person, right? The person will receive it. Okay, please learn the difference between both. It comes in the exam. Now, next one. TCP or IP uses domain name servers, that is DNS, that converts the numeric based IP address into text based address. Now, top level domain code is .com, .gov, .edu, .net, .mil, .org. You have learned this in internet in the web topic, right? .com. If you talk about .com, we are just
Commercial.
seeing. Yeah, I know it's commercial, right? But we are seeing .com, right? Letter C, letter O, letter M. That's what we are seeing, right? But in the internet, .com is a IP address. It's a different. It understands numbers, right? Okay? In the internet, even the computer, everything is according to numbers. 192.168.1.2, also 192.168, all these different numbers, right? It's a 12-digit number, 12 or maybe less than that, 10, right? So that's what I'm trying to explain you, right? The numeric base, that is the number based IP address, is converted to text based. .com is a text based IP address. A text based address. IP address of .com is something else, right? If you Google it, you might find it. Right? When you get time, please Google what is the IP address of .com or what is the IP address of .gov, right? And then, so that's what TCP IP does. Now, another very important thing, bandwidth. bandwidth.
Okay.
Right? You must have seen one-way bridge and two-way bridge.
To average
Right? Some places there is only one way. Right? One-way
video.
bridge. You must have seen in Tavua, a very good example. Right? One-way bridge was here before. Oh, still here, no way.
No, sir.
No way. Before there was
Not
one-way
to average.
bridge. Right? So one-way bridge, what happens? Only the vehicle
One party can
one side, yes. From one side the vehicle will go, other from other side, it has to wait. They have to wait, right? Now that's bandwidth. How fast traffic can flow, right? Bandwidth. How fast traffic can flow, right? Now this is similar to what happens in the network traffic, right? The data, right? If the bandwidth is more, then the volume of the data that will be transmitted will be fast, right? You'll be able to access YouTube and other applications very fast, quickly, if you have a good bandwidth. If the bandwidth is less, then accessing time will be very slow. You will find problems in accessing internet. So let me discuss. Bandwidth is the capacity of the communication channel that determines the volume of data that can be transmitted in a given amount of time. That is
time.
how much data can be transmitted in a given amount of time, right? That is called speed. The speed at which data can be transmitted, right? The speed at which you can download something, the speed at which you can upload something, right? That is determined by the bandwidth,
Bandwidth.
right? So this is a, you should know this definition, right? Okay, this, you can see the this diagram, right? Right, communication, video, graphics, and so on. Right? Remember, videos will take if you want to see videos in the internet, right? It takes lot of space, right? It takes lot of bandwidth, right? The bandwidth is less, then the time it takes a video to upload or download will be very slow, very less time. I mean, very lot of time. Sorry, right? So don't have to. I think I'll not have to discuss anything here. Next one, the four categories of bandwidth, right? Voice band, medium band,
Medium
broadband, and
band.
bass band. So these are
By
the four categories I will discuss today. First one, voice band. Voice band, talking about voice. Now, voice band, also known as low bandwidth, is used for standard telephone communication, meaning the TFL one, the landline telecommunication telephone, right? You can just pick up the phone, call, and then put it down. Not your mobile phone, right? The normal telephone communication, right? In the mobile phone, you can do video call also, right? But in a landline one, you can't. You can just dial and you can just put in the ear and call. See the patient from that side, right? So is used for standard telephone communication. It is effective for transmitting text documents. However, it is too slow for many types of transmission,
transmission,
right?
including high quality audio and
Including,
video.
yes, including high quality audio and video. So it will be very slow. See, voice band has very low bandwidth. That's why it is very slow, right? So as I said, if you have low bandwidth, things will be very slow, right? If you have high bandwidth, then uploading and downloading things will be very fast. So this was voice band. Let's see what is medium band. Is used in special leased lines to connect servers as well as transmit data over long distance. This bandwidth is
Is
capable
capable
of very high speed data
data
transfer.
transmission.
Special lines to connect servers, right? Remember, servers need a very high bandwidth. Why? Because servers are the main computers, right, which shares information to other computers, right? As I said, uh, I think I have not told you people, maybe another class, but um, just like, for example, there are many, the Coats, Coats is one company that is Fiji White, right? But where is their main seva? You know that, right? Main seva is in Samambula, Sufa, right? But see, it is using a very, it is using special lease lines to connect uh, to
Well,
right, for data to be transmitted over long distance, right? So someone from Ba can easily connect to the Seva and Suba.
yeah.
Don't take too much time to look for information, right? So this bandwidth is capable of very high speed data transfer, as I said, medium band, right? So over long distance, right, and you can connect Sevas. One Seva can be connected to another Seva, right? One Seva in Suba, another Seva in Tavua. You can connect, right, using special lease lines. That was about medium band. So just remember, voice band had low bandwidth, medium band has
Hi.
high bandwidth, right? Now let's see bandwidth. Sorry, broadband. Now broadband is widely used for DSL, that is digital subscriber line, cable, and
Well,
satellite connections to the internet. See,
yeah.
satellite connections. So this one is able to connect to satellites, right? That means the wireless. Several users can simultaneously use a single broadband connection for high-speed data transfer, right? So you can use just one broadband connection, and many people can use only one, just like your modem, right? The router that you people have, right? One router in at home, and 4, 5 of you can connect to that router and connect to the internet, right? And whatever you access in the internet, it goes through the satellite, right? If you want to call someone in a messenger, and that person is in Australia and is not anywhere else, right? It will go to the satellite, right? And then it will go to that person, right? The signal. Right? You'll not be. It's not that you are calling. It is just flowing in the air and goes directly to that person. No, you are connecting your phone to the satellite to that person's phone, right? So that's what broadband. Right? Just like in school, there's only one router, and from that one router, which is placed in the library, right? All the computers in the school is connected, right? The whole network is connected, right? So one router is providing the internet, and everyone in school can access the internet in the PC, right? That's broadband. Now last one is baseband. Is widely used to connect individual computers that are located close to one another. Like broadband, it is able to support high speed transmission. Unlike broadband, however, baseband can only carry a signal at one time. So see, broadband can carry, can communicate, can allow simultaneous access to, right? Many people can simultaneously connect, right, using broadband. But baseband, only one, it
Individual
will carry
computer.
a signal at a time, right? It is still fast, it is high speed transmission, but one signal will be carried at one time, right? So out of these four, right, which one is the best one? Anyone? Voice band, medium band, broadband, and baseband. Which one? Yes, Krisha.
Yes.
Which one? Which one is the best one for transmitting data?
Mm,
Come on. This one is very slow. This one is fast over long distance. This one, plenty people can access.
so this one.
Yes, it's broadband. Why? Because
Broadband.
it is connected to the satellite, and several users can simultaneously use the single broadband. Just one broadband and many people can connect to that with high speed data transfer. Right? Thank you. Good. Now my class was just till here. I wanted to just discuss till here. I don't want to pressure people, but I have I think 1-2 videos here for you. You can see on the videos are on this whatever we have discussed. So just see and then try to understand. And maybe you don't understand.
So let us try to understand the relationship between different layers of the TCP/IP stack with the help of a real-world analogy. So suppose we have this gentleman, and this gentleman has packed his luggage because he has decided to move from his current residence to a new residence which is few miles away from his current residence. And for the purpose of transportation of his luggage, he has hired a courier company called Movers and Packers. So let us try to map various elements of this situation to the TCP/IP stack. So this gentleman who is looking to be transported to his new residence is an application, and his luggage is an application data. And his luggage is well packed so that it do not get damaged during the course of transportation. So this function can be mapped to the session and presentation layer, because the session and presentation layer is responsible for encryption and decryption of data so that this data cannot be compromised while it is on the journey over the network. The courier company is equivalent to the transport layer. Now in the transport layer we have two famous transporting protocol, which is TCP and UDP. So if this courier company takes the responsibility to safely transport your luggage to the destination, then this courier company behaves as a TCP protocol. Otherwise, if the transport company do not takes the responsibility about the safety of your luggage, then this courier company behaves like a UDP protocol. So this courier company is responsible to transport your luggage from your current residence to your new residence, and therefore this courier company acts as a transport layer. The new apartments which this gentleman is shifting is like a destination IP address. Now coming to the road can be thought of as a network layer because road is a path from your current residence to your new residence. So network layer is actually responsible to take your data from source machine to the destination machine, and finally the various traffic signals which the vehicle will encounter on the road can be thought of a data link layer, because the vehicles passes through these traffic signals in a hop by hop fashion. So this is a good real world situation where different entities in this situation and the function performed by those entities could be mapped well to different layers of the TCP/IP stack.
Topic is the difference between baseband and broadband. First, baseband. Baseband means two different things in the networking field. 1. Baseband is related to digital signal transmission, where the entire bandwidth of a baseband system carries only one data signal at a time. In other words, every single signal would require an exclusive use of the shared media. When I use the media, for example, no one else could be able to use it. They must wait their turns. Ethernet is an example of the baseband system. Regardless of their different versions, whether they are early Ethernet, fast Ethernet, or 10 gigabit Ethernet, they all contain the word base. They are baseband. 2. Baseband also refers to the original frequency range of an analog signal before it is modulated to a different frequency range. For example, an audio signal may have a baseband range from 20 to 20,000 Hz. When it is transmitted on a radio frequency, it is modulated to a much higher frequency range. AM and FM are two common modulated technologies in radio broadcasting. Now let's talk about broadband. The term broadband technically refers to any type of signal transmission technique that carries two or more different types of data in separate channels. Broadband signals can share one media. It's like a multi-lane highway. Two or three vehicles can share the highway side by side at the same time. Broadband is also used as a marketing term for Internet access. This meaning is only distantly related to original technical meaning. In popular usage, broadband Internet refers to any high-speed Internet connection such as DSL, cellular, cable modem, or satellite. However, the broadband definition differs from country to country. In North Korea, the broadband may not be qualified as the broadband in USA. In summary, baseband is related to digital signals while broadband is related to analog signals. Baseband system does not allow a digital signals to share one media simultaneously, while broadband system can transmit different data side by side at the same time. For analog signals, frequency division multiplexing, or FDM, is used to make analog signals share one common media. For digital signals in a baseband system, time division multiplexing, or TDM, is used to transmit different users' data over one common media. TDM divides time into slots or intervals and assigns them equally to these users. In this way, everyone has an equal share. In general, baseband system is transmitting less amount of data than a broadband system.